Hello again, everyone. So for the continuation, we will be discussing the fundamental principle of counting. So fundamental principle of counting, or we also call this the FPC. So if an operation can be performed in n sub 1 ways, and if for each of this, a second operation can be performed in n sub 2 ways, then the two operations can be performed together in n sub 1 times n sub 2 ways. So this is called the fundamental principle of counting. So let's take this as an example. Consider that your house is located at Benavista, Luzon del Norte, and you are to travel to CSU. From Benavista to the city proper of Butuan, you're going to ride either a bus or a jeepney. Then, from city proper to CSU, you can choose either to ride a jeepney or a motorcycle. How many arrangements of mode of transportation can you choose from if you are to travel to CSU from Benavista? So, we can use FPC for this problem. So there are two operations involved in this problem. We have n sub 1, which is equal to 2. This represents the ways travel from Benavista to Butuan city proper. So you are going to ride a bus or a jeepney. N sub 2 are the ways to travel from Butuan city proper to CSU. So there are two because you can either ride a jeepney or a motorcycle from Butuan city proper to CSU. So we have n, which is equal to n sub 1 times n sub 2, which is just equal to 2 times 2, which is equal to 4. Hence, there are 4 arrangements of mode of transportation for you to travel from Benavista to CSU. So let's take a look at the 4 arrangement. So it's either from Benavista to Butuan city proper, you will ride a bus, then going from Butuan city proper to CSU, you will ride a jeepney or bus, then you will ride a motorcycle. Or you can ride a jeepney, then also a jeepney. And we also have you ride a jeepney from Benavista to Butuan and ride a motorcycle from Butuan city to CSU. Another example, how many 3-digit numbers can be formed from the numbers 3, 4, 8, and 9 if A, no digit is repeated, and if B, repetition of digit is allowed. So if you form a 3-digit number among 3, 4, 8, and 9, so there will be 3 operations involved in the problem. So the possible numbers to be put in the first digit, the second digit, and the third digit. For the first condition, we have n sub 1 is equal to 4. Okay, that is 4 since there are 4 numbers to choose from. N sub 2 is equal to 3 since there are now 3 numbers to choose from because no digit should be repeated. And then we have n sub 3, which is equal to 2, again, since there are only 2 remaining numbers to choose from. Therefore, using FPC, we have n sub 1 times n sub 2 times n sub 3. So you have 4 times 3 times 2 is equal to 24. Hence, there are 24 3-digit numbers to be formed if no digit is to be repeated. In the second condition, digits are allowed to be repeated. Okay, so we can say that n sub 1 is equal to n sub 2, which is equal to n sub 3, which is equal to 4. Since again, There are four numbers to choose from, and the digits can be repeated. So basically, if 3 is the first digit, 3 can be placed in the second digit, and 3 can also be placed in the third digit. Hence, using FPC, we have n is equal to n sub 1 times n sub 2 times n sub 3, which is equal to 4 times 4 times 4, which is equal to 64. Hence, there are 64 three-digit numbers to be formed if repetition of digits is allowed. Thank you for listening. So if you have more questions, please do not hesitate to ask your instructors. Up next, we will be discussing permutation. Stay safe.